2.1a is on function. So we want to be able to identify a function by a graph and a table, and we want to be able to find the range of a function given the domain. So let's talk about what a function is to start off here. There are a couple different things. Basically, a function, we can represent it as a graph, as a table, as an equation. So let's look at some graphs here. On the left-hand side of our page, we have 3 functions. On the right-hand side, we have 3 examples of graphs that are not functions. So when you're looking at a graph, the way that you tell if it is a function is to ask yourself, does it pass the vertical line test? In other words, could you draw a vertical line, right? Any vertical line on that graph, could you draw a vertical line and have it only hit one point of the graph? If the answer is yes, it is a function. For our not functions, well, let's try drawing a vertical line. It hits 2 points. Here, if we draw a vertical line on the y-axis, we're hitting 2 points. Here, if we draw a vertical line, we're hitting 2 points. And so since we hit more than 1 point, it does not pass that vertical line test, so it is not a function. So again, one way we can represent functions is just by graphing them. Another way to represent functions is a table, so a table of values. So we have our x and y table of values. So for a function, each input x can have only one output y. Repeat that to yourself. Each input x can have only one output y. So for example, if we're looking at our functions, let's look at our points. So all of our points, if you think back to your graphing, they have an x value and a y value that tells you where the point is at on your graph. So this point right here would be a value 2 for our x and 0 for our y. And we have a value 3 for x and 1 for y. Then, let's see right here, this is a value 1 for x and 1 for y. So notice that all of our x values go to 1 and only one y value. Same down here, we have the point 0, 1, we have the point 1, 2. Every x is going to exactly one y value. Now, looking at our not functions, well, let's look at a couple of points. Here we've got the point 0, 1. Here we've got the point 0, negative 1. But look what happened. We have one x value, the x value of 0, but it goes to 2 different y values. That cannot happen, so that is not a function. Down here on our second example, well, we have the point 0, negative 1. And then 0, negative 2. Again, it's that 0 going to 2 different inputs, right? I'm sorry, 2 different outputs, so that cannot happen, so this is not a function. One last thing that you want to take note of, every input can have one and only one output, but an output could have more than one input. So for example, in this graph, 3 goes to 1 and 1 goes to 1. That's okay. It's just when you have something like 3 going to 1 and 3 going to 4. That is not okay. So this is our functions as tables. So what is a function? We've looked at a graph, we've looked at a table. A function is when you have, for every input x, there's only one output y. So basically, it's an equation. It's a formula that for every time you put it in x value, you will have one and only one possible resulting y value. Okay? So when we think about a function, we can compare it to different applications or different things in our lives. So for example, we have a picture of a vending machine right here. So a vending machine is an example of a real-life function. So for our vending machine, our input, right, our input would be whatever option we want. So say we want to pick the button like A1, right, A1. We want whatever snack is in there. The function is what the actual machine does. Right, so the machine reads your selection of A1, it figures out which snack it is, and then it gives you your snack. And then the output, so say A1 was for M&Ms, our output would be our M&Ms. Okay. And the only possible thing that we could get by plugging in A1 is M&Ms. That's a function. All right, that's what a function is. You have some type of input, whatever it may be, your function does its job, and then you get and a resulting output from it. Okay, so our vending machine is a really good example of a function. So for example, if you type A1 in, you're going to get M&Ms every single time. So that's our input X having one and only one output Y. If you type in A1, you will never get Starburst, because that's not how your vending machine works. That would not be a function. All right. So this would be a good time to pause and see if you can think of another appliance or machine or something in your life that has that example where you put one input in and you can only get one resulting output from it. We also have something called function notation. So we may use f of x, g of x, h of x, and so on when we know an equation is a function. So here are two examples of functions written as equations. F of x equals 2x plus 7, and g of x equals x squared plus 10. Okay, so the x in f of x is the input value. So it represents any possible x you could plug in there. X could be 0, x could be 100. It represents any possible x you could put in there. That's why it's just an x. It's just holding that place so we can pick any number we want. So f of 2 means we are inputting 2 for x. Right, so f of 2 means we would be plugging 2 in for the x value, and then we would evaluate that function. One more note, f of x and g of x are the same as saying y. So saying f of x equals 2x plus 7 would be just a different way of saying y equals 2x plus 7. Okay, so function notation, it's just a special notation we talk about so we can denote functions, so we could talk about two equations at a time, f of x and g of x. That is the purpose of function notation. We're also going to talk about the domain, which is all the possible inputs of a function. So it's all the x values. All the x values you could plug into a function. And the range is all the outputs. So it's all of the y values that you get from plugging x in. Okay, so it's those resulting values. So this is a lot of different information. So we are going to look at a couple of examples to cement what a function really means and what we're looking at with this. So we want to give the range for the given domain. So letter A, we have f of x equals 3x plus 1. Now this is a function represented as an equation. We could also graph this, which we will do in this unit, or we could write it as our xy table, which we will also do in this unit. Okay, so these functions, there are a bunch of different ways to represent them. That is why we've looked at our equations, our graphs, and our tables in this one video, because we're just laying out all of the groundwork we need to talk about our functions. So letter A, we have f of x equals 3x plus 1. And we have three domain values. So remember, our domain values are our x values. So what this is really telling us is that we want to find out what happens when x equals 0. We want to find out what happens when x equals 4. And we want to find out what happens when x equals 5. These are our inputs. Okay, inputs, x values, those are the same thing. So we are going to take our x values and we are going to plug them in to our function. So instead of f of x, we want to figure out what happens at f of 0, or in other words, when x is 0. So notice how I rewrote my function exactly. I just have my value for x instead of the letter x. And now we just solve. Well, 3 times 0 is just 0. 0 plus 1 equals 1. So f of 0 is 1. Then we're going to do the same thing with f of 4. Well, f of 4 would equal, instead of 3 times x, it would be 3 times 4 plus 1. Well, 3 times 4 is 12. 12 plus 1 is 13. F of 4 equals 13. Now would be a good time to pause and see if you can figure out f of 5. F of 5 equals 3 times 5 plus 1. 3 times 5 is 15, plus 1 would be 16. So f of 5 is 15. So when we have the domain values of 0, 4, and 5, our resulting range are the values 1, 13, and 16. And that would be our answer because that is what we were asked to find. So all we really did, we took three x values, the three x values they gave us, the three inputs, we plugged them in to find our range or our outputs. So let's look at one more example like this. We have a different function here. We still want to find the range. We have f of x equals 5 times x minus 4 plus 1. And in this problem, our domain is -2, 4, and 10. So these will be our x values or our inputs. So let's see what happens with x equals -2 with the input of -2. Well, we would rewrite our equation. We just have a -2 in it instead of the x. And then we solve. Well, I'm going to simplify my parentheses first according to PEMDAS. So we have -2 minus 4 is -6. 5 times -6 is -30. -30 plus 1 is -29. So f of -2 equals -29. Now would be a good time to pause and figure out f of 4 and f of 10 to make sure you really understand what's going on here. F of 4, we have 5 times 4 minus 4 plus 1. Again, all we're doing is replacing that x with whatever value is given to us in our domain. Well, 4 minus 4 is 0, so we have 5 times 0, which is just 0, and 0 plus 1 is 1. So f of 4 equals 1. Last but not least, we need to figure out f of 10. Well, we would have 5 times 10 minus 4 plus 1. Well, 5 times 10 minus 4 is 6 plus 1. 5 times 6 is 30, and 30 plus 1 is 31. So we have our range. Okay, our range or our resulting outputs from the three given inputs is -29. Right here, -29. So I forgot my little bracket. Then I have 1 and 31. And you do need to write your answer in this form. Right? The domain is given in this form using the brackets, so you need to write your range in that form using the brackets. So we went over a lot of different stuff, but just to sum up, when we're looking at a table of x and y values, okay, x values only have one unique y value. A function, in order to be a function, it needs to be able to pass the vertical line test, so you need to be able to draw a vertical line anywhere on the graph and only hit one and only one point. And then our domain is all of our input or x values. Our range is our output or all of our y values.